This takes us to the Lami'S Theorem. And what does the Lami'S Theorem state? It states if three coplanar forces act at a point, keep a body in equilibrium, each force is proportional to the what? The sine of the triangle between the other two forces. And what is the expression? The expression is giving F1, which is force 1 over sine alpha, equal to F2, which is force 2 over sine beta, equal to F3, which is force 3 over sine gamma. Very easy formula. So this is the expression of the Lami'S theory. That's what it entails. So it's telling us that the force acting on a body is directly proportional to the sine of the angles, okay? The angles between the two forces. That's what we have here. All these sines, sine alpha is the angle, sine beta is the angle, sine gamma is also the angle. So the force is directly proportional to the what? The angle between the other forces. All these are the other forces, force 2, force 3, okay? The angles between the other forces. Force 1 over its angle, sine alpha, equal to force 2. All these are the other angles, okay? Angles represented, okay? It's telling us that it's equal to, is directly proportional to the forces of other angles. Since they are all equal, you can pick one. They might ask you, they might bring this one and ask you to find this, force 3. What is force 3? Since they are all equal, they are all directly proportional, meaning that the one they give you is still the answer. As easy as that, Shikina, easy peasy. Application of the Lami'S theorem. What is the application? It is used to solve problems involving three forces meeting at a point. As simple as that. For example, what are those kinds of problems? Pulley, okay, pulley, you know that pulley is a type of machine, and string, okay? Pulley and string. That's that for that. Principle of moments. What is moment? Moment of force is the turning effect of a force about a fixed axis or a fixed point. The turning effect, when we explained rotational motion, okay, where we used the fan blade as an example, the fan blade rotates or it turns about a fixed point, okay, the axis, okay, about a fixed point. I hope you also remember the difference between the rotational motion and the spin motion. The spin motion is the same, it has the same definition with the rotational motion, in that in the spin motion, the body is rotating on its own axis, about its own axis, okay. So that's the difference. So what is the principle of moment? For equilibrium, the sum of clockwise is equal to the sum of the anticlockwise moments. As easy as that, easy puzzle. That's why when you are solving questions related to moments in your Jamb UTME, what you do to finally get your answer is to divide. Since the sum of the clockwise is equal to the sum of the anticlockwise, you divide both sides following these rules, okay? You just divide and get your final answer. As easy as that, easy peasy. The sum of clockwise is equal to the sum of anticlockwise. When you say clockwise, what is clockwise? Clockwise is ascending, okay? When you are drawing a circle now, from here, from this point, okay, from this point, this ending point, like this, to this upper point, is clockwise. So from here, from this midline, okay, like this, is clockwise. Then from here, downwards to this other point here, is anti-clockwise. So ascending is clockwise, descending is anti-clockwise. As simple as that. You can also call this counterclockwise, okay? It is also called counterclockwise or anti-clockwise. So, moment of a couple, torque, couple and torque. I am going to explain what a couple is and what a torque is, okay? A couple is an equal and opposite force with parallel forces acting at different points. So, that's a couple. How do you create a couple? Let me show you the simplest way to create a couple. Maybe you want to open a tap of water, okay? You use this, your two fingers, okay, to open the tap, okay? Your index finger and this your thumb to open the tap, okay? You know that the tap, that's the bar of the tap, what you normally use to open the tap, it has two sides. So you are going to put this one on one side and put this one on the other side, okay? And you are going to apply force to the direction, okay, that you want it to loosen in, depending on the direction that it normally loses. Normally is the counterclockwise direction, okay? When you turn it counterclockwise, it's going to open up. So while you are turning it, the force on this finger, your index finger, and the force on your thumb are equal and opposite. So that force, those two forces, equal and opposite force you are using to turn that tap, that head of that tap, is called couple, okay? Couple, that equal and opposite force on the two fingers, for example. Then what is torque? This torque that you are seeing here, this one, this torque. The torque is that motion, that circle, and that motion, that movement, that circular movement you made as a result of the couple. As easy as that, easy peasy. So I just gave you. So couple induces torque, okay? Couple induces torque. Torque is the end point of a couple, okay? Hope you understood me clearly. So the essence of creating a couple is creating a torque. To form a torque, that's why you create a couple, to form that motion called torque. That's why it's circular motion, okay, brought about by a couple. So what is the expression? The expression is torque is equal to force times distance between forces. So the two forces, equal and opposite forces. The distance between these two forces times the force itself, okay? The distance between the two forces times the force required, the equal and opposite force required to turn times the distance between. This is the expression of torque. Application of principle of moment. Where are they applied in? Where do they apply? Jamb want us to know this. That's why they brought it. So they want us to know this. They told us, yes, we are going to set questions from here. Okay, the application of what? Moments. The first one we have there is lever system. Okay, like the seesaw, lever system. You know what a lever system is now? A system or a machine containing load, effort, and fulcrum. Okay, or load, fulcrum, and effort. So, and what determines the class of the lever is where the fulcrum is located in. Okay, you can either have the fulcrum in between the load and the effort, or you have the load in between the effort and the fulcrum, or you have the effort in between the load and the fulcrum. So that's what determines the class of the lever. Okay, crowbar is another one, lever system. To apply the principle of moment when you use all these tools. Okay, remember, you are doing something clockwise and anti-clockwise. There is always a rotation. There's always a couple and a torque. Another application of the principle of moment, steering wheels. Remember, I told you equal and opposite force. When you are turning the steering wheels, you are giving equal and opposite forces with both of your hands. Okay, and when the steering rotates, that forms a torque. That's a torque. The rotation is the torque. While the two equal forces, the two equal and opposite forces, one is going this side, one is going this side. Two equal and opposite forces like this, they are not going the same direction. They can't meet. Okay, that one is the couple. But that rotation, that circle created by the couple is called torque. We also use it in spanners. We use it in door handle. Any tools at all involving rotation. It follows the principle of moment. So couple in engines. You know couples in engines now. Rotation. That's it. The rotation in engines. The rotation required to move a car or to move a machinery or to turn a moving part of other machineries. Okay, that's a couple. So screwdriver, counterclockwise when you are losing, then clockwise when you are tying. As simple as that. Anything that involves rotation, it follows the principle of moment. And what? Rotating machinery, like I explained. Conditions for equilibrium of rigid bodies. What are the conditions to have a balanced rigid body? Remember what we said when we treated equilibrium of forces, okay? For equilibrium is equal to 0. And that shows that the force is equal to 0 when the system is at equilibrium. Moment also equals to what? 0. And the next is non-parallel forces. This one is for parallel forces, so force equal to 0. Moment also equal to 0 for parallel forces. Then for non-parallel forces, for equilibrium, the Fs, that's on the S plane, is equal to 0. The force on the S plane is equal to 0. While the force on the Y plane equal to 0 too. And moment equal to what? 0 overall. Then resolution of forces. It states any force can be what? Resolved in two perpendicular components, horizontal and vertical, like we explained in the vector graph. Okay, vertical and horizontal. That's how you resolve forces. Resultant. Single force equivalent to combined effect of two or more forces. Like we treated it in vector, the resultant is what? The single force equivalent to the effect is going to give the effect of two or more forces when they are to act. Okay, it's a single force, but it gives the effect of two or more forces when it acts. So that's resultant force or resultant. Equilibrant equal in magnitude but opposite in direction to what? To resultant. Equal in magnitude but opposite in direction to what? Resultant. Balance the system. So equilibrant what? Balance the what system. So all these are the conditions for a body to be at equilibrium. Okay, a rigid body. Parallel forces. Non-parallel forces. For non-parallel forces, for parallel forces, you have to have something like this. Force equal to 0 on the Y plane. Force equal to 0 on the S plane. Moment equal to 0. For all these, resolution of forces. All these are required. Resultants. All these are also required. Okay. The equilibrants. All these are also required. It balances the system equilibrants. Center of gravity and stability. Center of gravity, CG, is the point through which the entire weight of a body acts. Is the point through which the entire weight of a body acts. As simple as that. For example, the center of gravity of men is in their upper body. So as a man that I am, my center of gravity is located on my upper body from my tummy upwards. That's my center of gravity. That's where my weight, the weight of my body acts. It's not where the weight is located, though. Where the weight of the body acts. That's the center of gravity. Where you have your strength on, where your weight acts on. That's your center of gravity. Then for women, the center of gravity of a woman is in her lower body. Okay? For women, their center of gravity is located on their lower body. That's from their waist downwards. That's where they have their center of gravity. That's where their entire weight, the entire weight of their body acts. Okay? That's why women gain more weight on their lower half. That's it. That's the simplest and most relatable example I can give to you guys. Types of equilibrium. What are the types of equilibrium? We have 3 types of equilibrium in physics. We have the stable equilibrium. Remember, we also have other types of equilibrium in chemistry, okay, like the static equilibrium and the dynamic equilibrium. That's for chemistry. Here for physics, we have 3 types of equilibrium, okay, because we are talking about physical equilibrium. We are not talking about chemical equilibrium. So these are physical equilibrium. We have stable equilibrium, we have unstable equilibrium, we have neutral equilibrium. And under stable equilibrium, what does the stable equilibrium entails? The body returns to what? Its original position when slightly displaced. It is stable. It always returns to that its original position when you slightly what? Displace the body. For example, cone resting on base. You know the base of a cone now? Cone is like this. The base round. A cone that is placed on its base, okay, the cone is placed standing on its base, and you go and displace it, you apply small force to it, it's going to, you understand, it's going to shake and what? Return to its original position because its equilibrium is stable. If it's too much, it will shake like this, shake, it will return to a normal equilibrium position. But let's look at the unstable equilibrium. When a body moves further away when displaced, that's when you have an unstable equilibrium, okay? The body moves further away when displaced, away from the original position. The body moves further away from its original position when displaced. That's an unstable equilibrium. It moves further away. Neutral equilibrium is going to shock you. That's why it's so easy to know what is stable equilibrium is. Stable equilibrium returns to what? Original position. Unstable equilibrium moves further away from its original position. Okay. For example, under unstable equilibrium, we have what? The cone balance on the tip. You carry cone, you go balance and for tip, put the tip. That place will be like V for cone. You use and make it a stand. If you displace it, it's going to move further away from its position. It's going to fall and assume another kind of position. Then let's look at the neutral equilibrium. Neutral equilibrium, for a body to be neutral, for a body to have a neutral equilibrium, the body stays in a new position when displaced. So an entirely new position. Entirely a new position when it's displaced. So the equilibrium is neutral. It goes to a new position when it's displaced. For example, ball on a flat surface. You put a ball now on the flat surface, you displace it, you roll it. It's just going to move to a new position. Shikina, bye-bye, bye-bye to your ball. Now that we have understood equilibrium, let's quickly test the knowledge we have acquired so far by taking some Jamb must repeat questions. Jamb must repeat question. Question 36. 3 coplanar forces act on a particle in equilibrium. If the forces are 10 Newton, 12 Newton, and 15 Newton respectively, the angle between the 10 Newton and the 12 Newton forces is 120 degrees. Using Lami'S Theorem, find the angle between the 12 Newton and the 15 Newton forces. A. 90 degrees. B. 120 degrees. C. 150 degrees. D. 180 degrees. What's the answer? Drop the answer in the comment section.